Ladies and gentlemen, welcome. My name is Adam Grodzki. I'm the CEO of 3S Game Studio, and I would like to welcome you on our talk about revolutionizing game asset loading with IPFS. On this talk, we'll talk about what is IPFS in general, how the technology underlying works, what is the problem that we are trying to solve with IPFS, what we believe is the solution, and how do we implement it in specific game engine integrations. Finally, talk about why we chose an IPFS for this specific integration, and what you can expect of us in 2023. And if we have enough time, we're going to have a Q&A at the end.
Thanks. So, hi, I'm Anshuman. I'm on the partnerships team here at Protocol Labs. So, Protocol Labs is the organization, the R&D organization behind IPFS. It's comprised of over 300 engineers trying to make the internet more open, resilient, and secure. So, IPFS is an open source set of networking protocols that's used for peer-to-peer decentralized file sharing and storage. And it's been used in production since its release in 2015, which seems very long ago now, and has over 50 million monthly users. And thanks to over 1,000 contributors on all of IPFS's repos, there are implementations in JavaScript, Go, Rust, but also native implementations for more niche use cases like satellite communications or integrations in browsers like Brave or Opera, and also even your commonly used Unix commands like ffmpeg or curl. So going under the hood for a second to contextualize the rest of the talk, I want to talk about the different networking protocols that go into IPFS. So on the top left, you'll see how IPFS actually structures data. It chunks data into configurable blocks and then builds up a Merkle DAG around the data. What this means is each unique subset of the data plus the entire tree up to the root gets its own content ID, or what you'll hear of as CIDs. And what this means is you get verifiability and versioning inbuilt to the protocol, because if you update any piece of the data, any subset of it, even one bit, all of the CIDs will change. And what that means is also for content routing and exchange, in that very simple example on the bottom left, the algorithms can actually figure out what subsets of the data actually need to be transferred over the wire. If only a subset of the data is being changed, you don't need to ship the entire update. And so going through the stack, content addressing, what that means is instead of location-based addressing, like, hey, find me this file in this folder on this IP address, all your client would do is ask, hey, does anyone have this file? And then for content routing and discovery, what it's basically allowing is for a client to figure out who are its peers in the swarm and who has relevant pieces of data in this distributed hash tree. And then finally, there are different algorithms for content exchange. So how do you actually swap the blocks of data? BitSwap and GraphSync are two implementations, but there are several more. And then finally, because of this inbuilt versioning and mutability, there are things like the IPNS, or InterPlanetary Naming System, or even CRDTs for strong eventual consistency across an entire swarm. So with that very quick intro, I'll hand it back to Adam to talk about the specific implementation of IPFS in gaming.
Thank you. So now knowing what IPFS is, we can talk about how we can implement it specifically in gaming. And I'll be showing a few examples. A few of them are made with Unity and few of them are made with Unreal Engine. But first, let's talk about what is the problem that we are trying to solve. So the biggest problem right now is that game size, when it comes down to fidelity, is growing exponentially. We have bigger open world games, we have 4K textures, 8K textures, everything is just growing in size dramatically. And as our drives evolves, they started to get really fast and really efficient in loading assets, but not necessarily a lot bigger. And that's especially a problem on modern consoles, when if you get one of the cheapest modern console, you can install basically just 2 AAA titles. And if you want to install another game, well, you have to delete one of the ones that you already have. So what can you gain by using this system? Well, first of all, you can dramatically reduce the installation size of the game, because you can just load the assets that are necessary to run the game as the core experience and load any other assets ad hoc when they are necessary. You don't need to install absolutely all packages for the game. You no longer need to run updates through specific platforms. And you can ship updates a lot faster. The updates distributed through IPFS are platform agnostic, and you can patch multiple platforms and builds at the same time. You can also load cosmetics on demand. You most likely, if you have a ton of cosmetics in your game, like sometimes in hundreds or even thousands, you usually don't need all of them at the same time when starting a match. So you can check in between multiplayer players what is necessary for everyone to display those cosmetics and load only assets that are necessary. It is also very useful for single-player games. If you have a game that is linear in its structure, you can preload only maps that the player can play at very specific time and start loading the next maps that you will be requiring. And for example, unload tutorial maps at the same time to save some disk space. You can also let your players decide what to keep, what to delete, or what they would like to pre-download, and just select the experiences that they would like to have available at hand. And also, it's absolutely fantastic for sharing user-generated content in between players. You can store very complex structures in binary files that can be shared in multiplayer experience through replication of CID, which is a very small amount of data, and replicated on client side. So here are some basic use cases. Those are being built in Unity. The basic use cases allow you to download or load directly into memory any text, so you can run data-driven games through JSON format text files. You can load images and parse them into textures and use them in materials dynamically. You can also load binary data, like aforementioned savegame files that can store basically any references and any data structures that you need, or just download any type of file that can be not even directly a game file. So you can download an FBX, and then you can load it with a separate pipeline, separate plugin into the game in a way that you see fit. You can also upload basically any kind of data in the same matter, and you get the data address CID that you can share with other users. For some more advanced use cases, we have built a small demo that you can also see at our booth. And to make it happen, we built a game using modular gameplay features in Unreal Engine 5. We built the game in modules. Those modules then are being built into chunks. Those chunks are being automatically uploaded to IPFS. A manifest file is being automatically created and stored within IPNS. And then when you are playing the experience, it is downloading the content that is demanded at a very specific moment. So you can preload maps, preload experiences or models when they are necessary. And to do all that, all you need is just 3 blueprint calls, really. So why use gameplay features? Gameplay features allow you to use data registries, so they can allow you to expand any data structures that they are holding in-game. It can be crafting table, it can be cosmetic skins, it can be a list of available quests and events in the game. It allows you to also update data layers and war partition content, and it allows you to load elements of the map on demand. That can be specific NPCs, elements of a map that was previously inaccessible, or anything that you need. They are very easy to work with in a team, and They are by design standalone, therefore multiple people working on multiple features do not override each other's work. So they're just natural to be used in a large team. And they are very extendable. There's a lot of events that you can trigger while loading a game feature and unloading as well. And you can create new behaviors for gameplay features without the need of modification of the engine itself. So you can still work on the stock engine that's being shipped through the launcher, but you can modify how game features are behaving. Of course, Unity doesn't have gameplay features like Unreal does, but it has its own way of distributing pack files that we are using. So even though the gameplay elements are different, the way that you are using it is as simple in Unity and Unreal. So here's a video of a small demo that we have built. And once you download the demo itself, it just loads this menu and the package distribution system, which is only 40 megabytes overall. And you can start downloading and interacting with different experiences at the same time. And as we loaded this map, the other experience that was triggered previously, it's still being downloaded in the background. Those triggers doesn't have to be widgets, it can be gameplay events. It can be accessing an area, completing a quest, or any other event that you specify in any way you want. If content is not available, it will trigger a download of the content and it will notify you as soon as the content is ready. So you can trigger another event automatically when you finish loading, or you can just notify the game that the content is ready and you can load it on demand whenever you need it, like in this example. So through interaction with this door, we have loaded the gallery and now we can enter the gallery. And inside here, we are loading some dynamic content from IPFS directly to memory to fill in those paintings on the walls. And from this gameplay experience, we can interact with any other gameplay experience that we might have. So the third gameplay experience was downloading in the background, and now that it's ready, we can interact with it. And this completely changes the game that we had at hand, and now we are in a racing game. So you can have multiple mini games and different experiences that are interconnected. They can be shipped as part of a single project. They can share experience points or achievements or anything you need. And you can fluently move in between those elements. Very cool stuff about that is that you can also delete elements that you are not using at a very particular time to just save some disk space. So who is it for? First of all, this is a very good CI/CD patching solution. We plan to build it in such a way, all the automation tools, that you will be able to patch your game on any platform you are running on in less than an hour. What you have to rebuild, you have to rebuild the feature that you are working on, and this will automatically update the manifest file, which will force every client to download the latest feature. You don't need to, you no longer need to build patching solution using a distribution system like Steam, where you have to make incremental builds of the entire game. It is also built with multiplayer in mind. The CID is only 32 bytes in size. You can create very complex structures, buildings, interior design, whatever you want on client side, then upload this entire structure into IPFS, then download it on the server by just replicating the CID, verify if the client can place such a structure in particular place, and then just replicate it down to all remote clients and rebuild on client side. So you can save a lot of bandwidth by doing that. And also it is amazing for asset sharing. And with this method, you can very easily do cross-game asset sharing. So you might have assets that are being used in your desktop client, which is built with Unreal Engine, but the same assets are being used on your mobile client, which was built with Unity. So why IPFS? like gameplay features already exist, chunk loading basically already exists. So we are using IPFS because it has certain advantages over hosting your files by yourself. It is by nature an open source system that is not controlled by any entity, and you are not putting yourself into hands of some corporation as a dependency. You cannot DDoS IPFS, while someone might be able to attack your FTP or HTTP endpoint to deny your clients access to files of your system. Also, it is absolutely amazing for game preservation, because as long as a single node decides to pin certain CID content, it will be accessible as long as at least one endpoint of the entire network shares that content. So if you create a game and even your company stops supporting the game, the files for that game will be accessible forever. And because IPNS is creating a manifest file which stores all the updates, you also preserve all the historical versions of your game as well. CIDs are being generated based on the content. So even if a malicious party get access to your storage, if they try to swap some of the game files to put some malicious code in it, it will change the CID of those files, which means that they will no longer be verifiable and therefore they will be discarded by the game client. And also because IPFS is open source, you can use third-party providers for pinning services, or you can host a node yourself and you can run it on-premise, or you can run it in any of the cloud infrastructure. So our goals for 2023 is most of all automation. We'd really like to make it so easy that conversion of a game that is using modular gameplay features or similar way of distribution files in Unity to convert into using IPFS in less than an hour. So it should be literally just few functions that you need to run and everything is being done automatically in the background. We also want to fully automate the build process, upload process, and management of the manifest files. We also are building a system that will allow you to load placeholder assets in place of assets that you are trying to fetch, so you don't bottleneck yourself with waiting for files that haven't been downloaded yet. And once they get downloaded, they will be automatically swapped to the final visual assets without any need of intervention from the developer. And we are building all our tools with multiplayer in mind. And all our libraries and everything is being shipped with the plugin, which means that you can build it with dedicated servers. So thank you for listening. That's everything when it comes out to the presentation. If you have any questions, we'll be happy to answer. Anyone?
Yep.
Is that working? Yes? Okay. So thank you for the talk. I was wondering mainly about third-party like Sony or Microsoft. Are they handling the TRC process and all that of a game that distribute with such a small executable files? Is that something that's concerning for you guys, or is that clear?
I didn't quite follow the question.
Okay, so basically when you want to update a game on Sony or Microsoft, you have to, send an update file that they verify and do all that process. But since you're like basically not doing that because you're downloading files on your own servers and all that, is that something that you talk about with them?
Yes. So basically, this is how it works right now. So if you are on multiple platforms, on Sony and let's say on Xbox, you could run your updates through IPFS directly and would update multiple platforms at the same time.
Okay, and they are okay with all the process of verifying that the update file and all that are actually complying with all TRCs and stuff like that?
I'm not fully familiar with how the process of verification of updates goes for Sony and Microsoft. That's something we should probably check with them exactly, but it is technically definitely possible.
Okay, thank you.
Hi, so let's say I'm not worried about shipping on other platforms or providers, and I want to do this 1 hour workflow where I already made my game as pretty modular, and now I want the modules to be IPFS compatible. What does that workflow look like? Can you just spend 45 to 75 seconds just like giving me like, here is your life for the next hour while you're like splitting these modules into IPFS form?
Okay, so basically if you already have a game built in modular way and you want to convert it, all you have to do is find all the places where you call the modules to be loaded or unloaded, and instead call a function from our library that is also loading and unloading, but also managing download, preparation, and mounting of the packages.
Thanks.
In the case where there isn't very many people who have that file, is there a system in place to make sure that files are always available on some spot in the network, either through like the game company's servers or something, where it makes sure that the files are always there, including older files if there's like an issue with a new file loading, or someone's been offline for a long time and something doesn't work?
Yeah, so basically there is something called the pinning service. Maybe you would like to take it.
I mean, you can think of it very similar to how it works today. Like if the gaming company exists, they're probably hosting it on their own servers regardless. That's the most guaranteed way they can ensure files are still available. But as long as anyone hosts it, it is available. So say the gaming company, 50 years in the future, the gaming company no longer exists. They've stopped paying their S3 bills a long time ago. There's no guarantee, like, because it's a decentralized system, there's no way to guarantee that any one person is hosting that file unless they are incentivized to do so, or they have some emotional connect with the file. But as long as one node is hosting it, everyone else can replicate it. So it's not so different from the current paradigm, except that other people can host it.
Yeah, so basically if someone decides that preservation of this game is important for him, he can make this call and just save it forever.
Hi, thank you for the talk, super interesting. You told, following that basically, what if a company accidentally publishes a file maybe 2 months too early? Is there a way to remove like files you leaked or something?
Oh, that's a tricky one.
Or you want to remove
No,
privacy
this is
data?
this is a great question. This was my first question when I learned about IPFS. There's no universal delete function, is the short answer, because it's peer-to-peer. Of course, the assumption with most of these files is they'll be encrypted, at rest or wherever it's getting uploaded from. So as long as files are encrypted, even if someone can replicate it, it doesn't, compromise any of the consistent data. But yes, if you publish, like if I publish data onto IPFS and I want to assume the worst case, I have to assume someone's replicated it, and there's no way for me I can find that node if they are broadcasting that they have it, but there's no way for me to take it down from a protocol perspective.
Clear. Thank you.
Thanks for the presentation. Inception style question. Can you use IPFS? You mentioned that you have a library to integrate it. Can you update a library using IPFS? Does it also work with like SDKs or binaries, or is it only for assets?
No, it's not only for assets. You can use it, but the library or SDK that you are using can be loaded at the moment of update. So, for example, you would have to force the user to get to the menu and then update it and then get back into the game.
So did someone do it successfully? Do you have like some examples?
I mean, you can visit our booth. We have a working demo that I was showing right here, and we're using a bunch of techniques in it. And we can even show you the code if you like.
Thank you.
Hey there. I was hacking on some IPFS stuff at one point, and I was trying to create a website where people would seed information instead of just download it. And I think the IPFS JS client wasn't at that time able to do that. I was just curious if in Unity or something, if it was now possible to have the game client seed to other game clients peer-to-peer rather than waiting for an update from like one of the pinning services or the server that the game developer would run.
Yeah, sure. I think Adam can answer specifically about the Unity implementation. Ultimately, like the answer is yes, in terms of if you run an IPFS client, and that could be run sort of in the background, then your internet, your wired laptop or whatever could be broadcasting and seeding that data. And that's where it comes useful for user to user, sharing content. For the specific implementation, if it's doing that today, Adam, do you want to answer that?
Yeah, so it is very much possible. You can make implementation of the protocol that is just partial. And actually, Protocol Labs have a partner that is like another game studio that is working on peer-to-peer exchange of IPFS CID-based files. And
cool.
We are actually in talk with them about possible integration into game engines.
Sick. I was just also going to add, you can also guarantee that it's available with Filecoin, right?
Yep.
Okay, thank you for the presentation. So it might be a trivial question because I'm pretty new to the space. But like, for example, I have a game of 50 gigabytes. So through this system, what do you think I should still keep locally? And then how much, reduction you guys can achieve for that game? Just as a trivial example.
So like, for example, that we have built, we came down from 2 gigabytes to 38 megabytes. That was necessary to actually run the game, which is quite a reduction. But on what you need to hold on premise to make the game still playable is actually just up to you as a developer. It is probably very little data that is really needed to load at very specific stage level, but you might also want to hold some legacy data that you were using previously for just, save point rollbacks or something like that, and start to preloading data that you need ahead of you. But you can make automation rules to, for example, keep your installation size below 15 gigabytes, and you can automatically delete content that is old and not used recently. Or you can just even make a list of assets and features that you have in game, and you can let the player decide what he wants to download. So you can either automate it, you can force someone to use this specific implementation, or give him free hand to do as he see.
Oh, so basically, like I just need to keep maybe just the games scenes or sessions that I currently need to use, and I don't need to download the whole game.
Yeah, exactly.
Okay, cool. Thank you.
What's the benefit of IPFS over like Microsoft CDN or something like that?
Yeah, I think there's a few, the answer differs for each level in that network protocol. I'm not going to say it's like blanket better, like, it's very hard to make that statement about anything. But for IPFS, I think the important first thing is the content addressing of data. That allows you to also use other systems. So if you use an IPFS-based system, you can also use, Microsoft's CDN, but it allows interoperability. So you can use Microsoft CDN and also host the content yourself, and have like the protocol will handle the content routing. So you don't have to like come up with specific strategies about how a client retrieves that. The other thing about a CID is that it's verifiable and it has versioning built in, which is important for games when assets get built up or change, or you might have someone, with user-generated content, you might have a lot of updates to it. So all of that tracking just comes inbuilt for free. I think the CDN is sort of the delivery layer, right? Whereas IPFS is sort of the protocol of how you put together the data. So I think those two work very much together. So for example, Cloudflare hosts an IPFS CDN, right? So that's because those two things interrupt. Sorry, long-winded answer to your question.
Yeah. Sorry, we got a sign that we can't take any more questions, so we're at the end of this session. But if you have any more questions, we have a booth on the second floor, and feel free to visit us.
Yeah.
Thank you very much for coming.